Welcome to Daily Papers, the podcast where we break down the latest and most interesting academic papers into something you can actually understand.
So today, we're talking about a classic student-teacher dynamic, but with a twist. We all know that AI models, or large language models, are getting incredibly good at a lot of things, including high school math. They can solve complex problems, often with perfect scores.
Right, they're the straight A students of the digital world. But this paper asks a different question. It's one thing to be a star student, but does that make you a good teacher, or more specifically, a good grader?
Exactly. The paper is called RealMath-Eval, Why SOTA Judges Struggle with Real Human Reasoning. SOTA just means state-of-the-art, so we're talking about the best AI models out there. The researchers wanted to know if these top-tier AIs can accurately grade the work of real human high school students.
And this is a pretty big deal. There's a whole field of research called LLM as a judge, where powerful AIs are used to evaluate the work of other AIs. It's how they get better. But the core assumption is that if an AI can solve a problem, it can also judge a solution to that problem.
The catch, which this paper points out, is that these AI judges are almost always grading other AIs. It's a very clean, closed-loop system, machines grading machines. But what happens when you introduce the beautiful messiness of a real human brain into the equation?
To find out, the researchers created a new dataset they call RealMath-Eval. They collected 224 real, handwritten math exam answers from actual high school students. We're talking trigonometry, derivatives, the works.
And then they ran a really clever experiment. They took some of the most powerful AI models, like those from Google and OpenAI, and gave them two sets of exams to grade. The first set was the real student work. The second was a control group of math solutions generated by other AIs, designed to mimic a range of student abilities.
And the results were fascinating. The AI judges were actually pretty good at grading the solutions made by other AIs. They were consistent and accurate. But when it came to grading the human students, they struggled a lot.
They found what they call a stark evaluation gap. The error rate for the AIs grading human work was more than twice as high as when they were grading other AIs. They were consistently getting the scores wrong, often by a huge margin. In over a quarter of cases, the AI's grade was significantly different from the expert human graders.
So the big question is why? Why are these super smart AIs so bad at understanding human work? Are the students just making mistakes the AI has never seen before?
That's pretty much it. The paper offers this amazing metaphor to explain the difference: the crystal versus the cloud.
The crystal versus the cloud. I love it. Tell me more.
Okay, so the crystal represents the mistakes that AIs make. When an AI gets a math problem wrong, its mistakes tend to be predictable and fall into very specific structured patterns. They're like crystals, organized, and they cluster together in a neat low-dimensional space, if you want to get technical.
So AI mistakes are formulaic in a way. What about the cloud?
The cloud represents human errors. Our mistakes are all over the place. They're idiosyncratic, noisy. Sometimes there are weird creative leaps that just don't pan out. There's no neat structure. Our errors form a diverse, high-dimensional, messy cloud.
And the AI judge is trained and familiar with the predictable, crystal-like errors of its AI peers. So when it's suddenly faced with this chaotic cloud of human mistakes, it gets completely lost.
Precisely. The researchers even measured this using a concept called surprisal. They found that the logical steps in human reasoning are far more surprising to an AI than the steps in an AI solution. When a student makes a mistake, the AI judge is basically thinking, "I have no idea how you got here. I would never have made a mistake in that way."
That makes so much sense. The AI can't follow the very human and sometimes very strange train of thought. But could this be a simple fix? Like, what if you just tidy up the students' work, rewrite their messy answer into a clean, typed format?
They tested that. They performed what they call style transfer, where they took the students' messy work and reformatted it to look exactly like a clean AI-generated answer, but they kept the underlying logic and the errors the same.
And what happened?
Almost nothing. The AI judges were still just as bad at grading it. The problem isn't the surface level messiness, it's the fundamental difference in the structure of human reasoning and human error. It's the cloud, not the smudged ink.
Wow, so the takeaway here is pretty significant. If we want to build AI that can actually work with people, like an AI math tutor, for example, we can't just have AIs training and evaluating other AIs.
Exactly. That approach creates an in-group bias where AIs get really good at understanding other AIs but fail to understand their users. This paper argues that to close that evaluation gap, we need to stop relying only on clean synthetic data.
We need to expose our AIs to the real deal.
We need to let them see the cloud, the diverse, unpredictable, and ultimately human way that we think, learn, and make mistakes. Only then can we build AI that is truly helpful.